this 10 to alpha. Again, I think this is really helpful. They put this screen up here. You need to read it. Like, okay, this is telling me I want the difference of means. X bar 1 to X bar 2. Conditions, confidence interval, and a test. So a test would be the test statistic. What is the test statistics for a difference of means? What are we talking about? Don't sit there, let me talk over you. You don't understand what that screen means, and say, what does it mean by test statistic? I hope you understand this. P-values we just talked about. What about the test statistic? The test statistic for a difference of mean is the t-score, because z-score goes with proportions and t-score goes with means. So we're going to compare these two. 10-year-old girls and 10-year-old boys. Does this make sense to you? We want to build this curve that's the difference in heights. So if I go over here to this curve and just mark it up. You can't see me at home, but it's not a big deal. It's drawing the curve and saying, ready? Boys take away girls. It could be girls take away boys. Doesn't matter. But the girls are tall. So we go girls take away boys. Ready? 0.7 is in the middle. That's the height of 10-year-old. Girls take away boys. Because the mean difference, girls take away boys, is 7/10 of an inch. And the challenge becomes in quantifying the value of the step. Because they gave us two different steps, one for girls and one for boys. So how are they going to do this? Well, they're saying, suppose we take 12 girls and 8 boys. What happened? Well, you have this. The sample size is not 30. No, it's not. But they told you that the population was approximately normally distributed. So the sample doesn't have to be 30. Here's the center for the girls. Here's the center for the boys. Here's the step for the girls divided by the square root of the sample size. You always do that. Why? Because if your sample size was 1, dividing by root 1 would not change the magnitude of your step. There's the boys, divided by root 8. Okay? And look how they wrote the subscript. Sigma. Sigma means the population, it's the parameter. Subscript G for girl, subscript B for boys. Not 1 and 2. So they did this simulation. Thousands of times, thousands of dollars. What happens? One gave you this. I don't know if I find that helpful. There's the center. Because the center is 0.7, just like our picture. And each time they did this simulation, they put a dot there. Now, what's the step? This is important, see? It's not difficult, but it's you got to pay attention to. They told you the girls' step, the population step was 2.7 inches. That's the standard deviation. We want to add the variances. So we have to square that. we square it and divide by the sample size. Well, boys, 3.8. Square it, divide by the sample size. That's the sum of the variances. Take the square root of that. That's the step in this picture. So I would go over here and say 1.55. That would take me to 2.25? And 1.55 take away 7/10 would be 0.85. That's what the steps would be. Or the difference in these, depending on those two particular sample sizes. So what do we got? Conditions, S or S. If the sample size is bigger, or they tell you that both population distributions are approximately normal. Just the difference of the means. There's the step. Where are we getting the step? Because you take the square root of the sum of the variances. And they gave you the standard deviations. So you have to square them to get the variance. Then you divide that by the sample size, which you always do, but you didn't notice it because the sample size was 1, you divide it by root 1. So we got this question. So again, I would build a two-way table to organize what's going on here. Because when you're reading this paragraph, you don't want to go back and forth between the two things. It's not really a two-way table, it's just an organization. And you're saying, all right, large soda has a mean and a step. And medium soda has a mean and a step. Because you don't want to be going back to the paragraph to get this information. And then you got a sample size. So for the large soda, 27 8/10. For the medium soda, 17 5/10. And the sample size, 20 for large and 25 for medium. Okay? Ready? I can do one thing. I can explain something to somebody who wants to learn if I understand it. That's it. I can't build things. I can't do much of anything outside of one small skill set. If I understand something and I'm discussing with someone who wants to learn it, I can explain it. And one way to get there is because I am organized. And some people have different levels of organization. That's something you can learn, right? It's not complicated. To do this problem, you write that on the side before anything else. Because if you're going back and forth and you know what you're doing and you put the number in the wrong spot, it doesn't matter if you know what you're doing. Like we had this a couple of years ago. We had scrap paper. Well, you were here last year, if you were in Texas. We had scrap paper we handed out to the assessors. Remember that? You don't remember it. You might have heard of it. We had scrap paper. Why? Because Arathi designed the scrap paper. And Arathi used to write on top of her blank scrap paper, A, B, C, D, E, for every problem. And then she would cross out the ones to eliminate the answers that was wrong. I'm like, wow, that's really good. So let's hand it out to everyone. They could use Arathi's method because she was really organized. She wasn't going to make a mistake She made mistakes, but she wasn't going to make a mistake because she was distracted or lost her place there. So take that, go there. What is the shape of the distribution and why? Find the center, calculate the step. Ready? Large follows a normal distribution. Medium follows a normal distribution. It's buried in there. What's the difference? This take away this. Pen's in the center. Large take away medium. Well, suppose I did medium take away large. That would be fine. -10 would be in the center. And you're just taking your picture and going like this to it. You'd get the same answer. You'd just be shading in the left instead of the right, or the other way around. Here's the step. They took this number, squared it, divided it by 20. This number, squared it, divided by 25, and they took the square root of the sum. Which means what? It means in your picture, for this sample size, you would have 10 in the middle, large take away medium, and every step would be worth 2/10. That's what it means. But it's really helpful to take, like we were drawing these pictures in October. Draw the curve so you can conceptualize what's being asked. So here's the conditions. Again, it's kind of redundant, but in a helpful way. You always have the screen there. SRS, less than 10% of the population or sample is, and then it's either approximately normal, we're told that, or the sample size is larger than 30. Well, how about the sample, how about if they're not told it's approximately normal, and the sample size is all right, sorry about that. All right, we're back to the PowerPoint. We thought we were. Okay, so next thing. You want to compare the cost of 1 and 2 bedroom apartments. Now what happened? Think about this. Instead of getting the summary statistics, instead of telling you the mean and the step, they gave you the data. So what that means is on your calculator, I can't do this without. What good at this? On your calculator, what that slide is saying is when you go stat, test, ready? We're looking at 4. It's a 2 sample t-test because it's means. And we're comparing 2 samples, large and medium drinks, 1 and 2 bedroom apartments. When we type 4, look what you get. You get this option. Am I inputting the data like you would be for the apartment problem? Because you'd put them in lists? Or am I doing the summary statistics where they're telling me the mean and standard deviation? So when you go there, that's why you're getting 1 of each on the PowerPoint. when you go to stat test, it's built in to which way you're going, which way you're being asked for this. All right. So I'm not going to do the whole thing, but if we say from that last problem, what about the sodas? I would say 27 for the large one. The step is 8/10. The sample size was 20, right? For the medium one, it was 17 was the center. The step was 5/10. And the sample size was 25. And then this would be a two-tailed test. Is there a difference between them? Right? We're a one-tailed test. When you see, I wanted to do this because this. When you see the word pool, never pool in here. Do not do it. Ready? That's why the default is against the left. No, first, don't pool. It's beyond the scope of the course. You don't pool in AP Stat. What happened? We get a p-value that's essentially 0. What does that mean? It means the probability of getting what we got or chance alone is essentially 0. There is a difference between the large and medium cups. Okay? There's no way that this, if you got a medium cup that had more soda than the large cup, that is extremely unlikely to occur. I just wanted to show you about that part. Why is Joey Choi in there now? All right, sorry, I got to go back through this. So now we're at the apartment problem. Okay? So we're going to test to see if the differences are not 0. So they say, all right, let's check the conditions. So there's the data. And what would happen here? You would put 1 bedrooms in list 1 and 2 bedrooms in list 2. You got an SRS. So we got that. Tells us that's how they got the sample. So yes, there's less than 10% of all the apartments. And then the sample size is too small. They're drawing a dot plot. We would draw a box plot. Does that make sense? You don't have to worry about this, okay? They're saying this. We're replacing the parameter with a statistic, so we replace the sigma with standard error. But your calculator does it for you. Don't worry about it. How about this? They built this table like we built this table. They just organized it different. Yes? And then what happened? The sample size is 30. So the sample size is large enough. But they drew the box plot anyway. What are we trying to do? We're trying to see if there's a difference between the trees in the north and the south. Well, the south trees are bigger. Yes, but we're going to test that they're not. We're going to test it for the same size. And maybe that difference can be attributed to chance alone. Just because they're bigger in this one sample of 30 each doesn't mean that that's statistically significant. Well, that looks big to me. No. All right. We went a little long here. Sorry, I was looking at the wrong thing. If you're at home, you're dismissed to do the exit ticket. Don't worry about it. It's open past 9:50. Make sense? So if you're home, you go through the exit ticket. You can take 9 minutes to do that if you want, and you'll still have time to get the third period. Okay? There seems to be skewness, ready? To the north. Skewness to the south, but not as much. So we want a 90% confidence interval for the difference. But we're going to test that the difference is 0. What'd you get? You got a confidence interval where both values are, calculator's doing this for you. You're getting a confidence interval where both values are positive. That's evidence that the trees in the south are larger than the trees in the north. Yes? Why? What are you looking for in the confidence interval? Because if zero's in the interval, that's telling you that you can't reject the null. See, the null is saying the north, the south tree, take away the north tree equals 0. That's the null. If 0's in the interval, F2R. If the interval goes positive to positive, or negative to negative, reject the null. 0's not in there, reject it. If 0 is in there, they'll reject it. What does that mean? It means that if you rejected the null from a confidence interval, that your p-value would be really small. And you'd be low in the alpha level. And if 0 is in the confidence interval, your p-value would be bigger than the alpha level because the test and confidence interval work together. All right? So